Welcome to Nature Revisited, a podcast that explores our relationship with the natural world. It consists of interviews, stories, and discussions that highlight the notion that nature is not a place one goes to, but rather a place one is already a part of, that we are nature. For those of you who are new to the podcast, my name is Stefan Van Norden, and thank you, everyone, for joining me on this episode with Paul Bierman, When the Ice is Gone. Paul Bierman is a geologist and professor at the University of Vermont. Paul's research has taken him around the globe to studying erosion in Australia, South America, Africa, and the Middle East. And more recently, his research has taken him to tracing the history of the Greenland ice sheet and what it reveals to us. Paul joins me from his offices in Burlington, Vermont, to talk about the Greenland ice sheet and what happens when the ice is gone. So, Paul, welcome to Nature Revisited. It's a pleasure having you on the podcast, talking with us today about your new book, When the Ice is Gone. So let's start with what inspired you to become a geologist and to study glaciers.
Well, let's see. Why I'm a geologist? My mother would say it's because I loved picking up rocks on the beach when I was a kid. And that's probably true to some extent. My bedroom was full of rocks and sand and fossils and those sorts of things. But really, it happened in college. I thought I wanted to be a chemist, and I needed one more class my freshman fall. It was a class on lakes and oceans, and so I took this class on lakes and oceans at the same time I was taking an honors chemistry class. And you know what? The lakes and oceans class was a whole lot more fun, and that was in the geology department. I loved being outside and doing science outside. That's what got me hooked on being a geologist, and then I met some really important mentors in my life who started me down the road on glaciers, and it's been that ever since.
So when did you first become interested in Greenland and the Greenland ice sheet?
That was a bit later in my life. I studied what we call the Laurentide ice sheet first. That's the ice sheet that overwhelmed all of New England and the Midwestern United States and Canada. And so my senior thesis at Williams College was spent looking at the deposits of sand and gravel left behind by the Laurentide ice sheet 16,000 years ago, 15,000 years ago. And then in the early 2000s, I started talking to people, particularly a fellow named Tom Newman, who's now at NASA, who was at the University of Vermont. We talked a lot about Greenland, and I have a toolkit that includes measuring some very rare isotopes, beryllium-10, aluminum-26. And Tom and I were talking about how we might be able to apply those to the Greenland ice sheet. And then a fellow named Richard Alley came up for a talk. He's a rather famous glaciologist. And Richard and I were chatting about what we could do with beryllium-10, and out of that came our proposal to the National Science Foundation. And the interesting thing about that is we were trying to determine the erosion history of the Greenland ice sheet and the timing of things, and based on sand that was pouring out in big meltwater streams. And the reviews on that came back, said, really interesting idea, really risky. It's probably going to fail, but it's worth trying. And so my first field season in Greenland was 2008, and we went back 4 years in a row after that to collect samples. And I was hooked on working on Greenland and the problems of when the ice sheet has been unstable in the past and how it behaves and how it erodes the rock and sediment underneath it and what's going to happen to it in the future.
So why is Greenland so crucial in understanding the future effects of global warming?
Greenland is important because it holds almost 7 meters of sea level, or 25 feet of sea level equivalent in the ice that is now sitting on that island. And so when that ice melts, the water streams into the North Atlantic, and every drop of that water that ends up in the North Atlantic makes global sea level just a little bit higher. Greenland, unlike Antarctica, is not as cold and it's not as isolated. So as the climate starts to warm, the Greenland ice sheet seems to be feeling it first. It's also been much more fragile in the past than Antarctica. with large amounts of the southern part of the ice sheet, we know disappearing 130,000 years ago and also about 400,000 years ago. So Greenland is way more fragile, and it holds enough water frozen in that ice to cause displacement of at least tens of millions of people around the world from coastal zones, from low-lying areas, should that sea level rise.
What was the military's interest in Greenland?
The military is a fascinating twist on this. Greenland was a place for explorers, sort of the early 1900s, the race to the North Pole. And then around World War II, people started to realize the strategic importance of Greenland. Now imagine that you're in Nazi Germany and you want to know the weather that's coming into this war theater in Europe. You have to look to the west because the weather goes from the west to the east in the mid-latitudes like that. And so Greenland was a logical place for the Nazis to set up weather stations during World War II. And of course, the Americans were similarly interested in Greenland, in part for understanding the weather coming to Europe so that they could fly airplanes across to Europe to support the Allied powers, but also because it held a particular mineral that was really crucial for refining aluminum at the time. And one of the only mines in the world that had this mineral was in Greenland. So there was really strategic interest in Greenland in World War II, and that's what got things started. It didn't hurt that those airplanes they were flying to Europe kept falling out of the sky. And one of the places they fell out of the sky was on the Greenland ice sheet, and of course the airmen needed to be rescued. And so there was a large portion of Army interest and Army Air Corps interest in understanding the ability to move around the ice sheet to rescue these downed airmen. After World War II, the strategic importance of Greenland changed because then we had the Cold War. On one side of Greenland was Canada and the United States, and on the other side was the Soviet Union. And the fastest path between Moscow and Washington was over Greenland, be it a bomber or an intercontinental ballistic missile. And so the military invested a lot of money and time and energy in the 1950s and up until the mid-1960s in learning how to move around and how to have bases in Greenland to ostensibly protect North America.
So when did scientists first start making the connection between carbon dioxide and global warming?
It's earlier than you think. The first connection is actually in the 1850s. A woman named Eunice Foote did the first scientific experiments to show that carbon dioxide is actually very efficient at trapping energy as a gas. Her work is largely overlooked. By the 1950s, mainstream scientists are quite aware of the potential for the change in atmospheric concentration of carbon dioxide. They have big questions. Some of those questions are, is that carbon dioxide staying in the atmosphere? Or is that carbon dioxide being dissolved in the ocean? And if so, how much? And if the ocean could soak it all up like a giant sponge, then they weren't so worried about the changing climate. But if the ocean didn't, it meant that Earth was going to warm. So a lot of work in the late 50s. And that is directly what led a fellow named Henri Bader, a Swiss geologist, who was trained in minerals, actually, and then made a switch into snow. He started to study avalanches in Switzerland before World War II. And then as war was looming in Europe, Bader left for South America. And he spent the war in South America and then in the Caribbean. And just after the Victory in Europe Day, Bader flew to the United States, became a professor at Rutgers, and was immediately hired by the Army to investigate snow and ice, and spent the rest of his career working on snow and ice, and was the strongest American advocate at the time for coring ice sheets to learn about the history of climate. A very fascinating man, and there are actually some recordings that are still extant of him talking about the importance of ice cores and the importance of understanding climate in the past. He's the one who really kicked off that whole field of using ice and ice cores in the United States and for the Army to understand changing climate.
Which kind of led to Camp Century. Where was Camp Century, and why is it so important?
So Camp Century was located in northwestern Greenland, about 130 miles down a snow road across the ice sheet. It was located at about 7,000 feet elevation, and it was this fantastical idea that the Army actually started developing in the early 1950s of putting men and machines underneath the ice. I shouldn't say they developed it. This was really a riff on what had happened in 1930. A fellow named Wegener, who is much better known for plate tectonics, he had an expedition to Greenland with about 30 men and 3 at the center of the ice sheet. And those men at the center of the ice sheet lived in a snow cave over the winter and survived and thrived and took scientific data. And so the Army, I think, had an inspiration from that. The French did the same in the 1940s. And then the Army, that is, started building camps under the ice, of which Camp Century was the finale. It could hold up to 200 people in insulated, heated buildings under the ice. It had a nuclear reactor for several years to power the camp, which was far more efficient than bringing in thousands of gallons of diesel fuel to run generators. And it was both a military outpost and it was a scientific research and engineering research outpost. It lasted from 1959, when they started building, till 1966, when it shut down. At that point, it was really no longer necessary, and the camp was closing in as the ice was deforming around it. And one of the last things that happened at the camp was the recovery of the bottom of the Camp Century ice core. At the time, the only ice core ever to be drilled through an ice sheet. It was nearly a mile long. And at the bottom of that nearly mile of ice, they recovered 12 feet of frozen soil.
So who was Lucibel Bledsoe?
So Lucibel Bledsoe is a very interesting character in all this. She worked for the U.S. Army Corps of Engineers, first in an office outside of Chicago, and then in New Hampshire at CREL, the Cold Regions Research and Engineering Laboratory. She was an English major, and she edited just about every technical publication that came out of the group working in the Arctic there, between when she was hired in the mid-50s and her very untimely death due to a house fire in 1966. She's exceptional in that she did not have any geologic or scientific training, yet she shaped the literature that we depend on for understanding a lot of the early work in Greenland. And what is most striking is her obituary was published in the Journal of Glaciology, which is the premier journal for understanding ice and glaciers. And very few scientists have their obituaries published in a place like that. So a real tribute to a woman who shaped the literature that we all now read to understand the early history of what went on scientifically in Greenland.
So how did the ice cores that were being taken at Camp Century, what you might call the Library of Ice, how did that show us about the Earth's past, present, and future?
So the ice core taken from Camp Century very soon was used to create the first record of Earth's climate that stretched back over 100,000 years. The person who was most involved, I would say, in the Camp Century ice core and many ice cores after that, as Bader was growing older and stepping away from active research, is a fellow named Chester Langway, who started with Bader in 1956 and actually drilled some of the first American ice cores not at Camp Century. And then he went on to complete, along with several other people, the drilling of this Camp Century ice core, and made a lot of alliances with some of the best labs for measuring the isotopes of water. And so by that I mean the types of oxygen and types of hydrogen were in water. And a fellow named Willy Dansgaard ran the premier laboratory in the world at that point. It was in Copenhagen. And so Langway and Dansgaard formed an alliance. They worked very closely together. And in 1969, Dansgaard published a paper that changed how the world thought about climate history. And it was called 1,000 Centuries of Ice. What it did was show that we were in a warm interglacial period. It then showed that we had been through a cold glacial period. And then it showed warming to another interglacial period. Now, people knew that from deposits on land, but the difference was that Dansgaard and his co-workers had a model of the age of the ice that they were analyzing layer by layer by layer. And this was thousands of samples. And they could put a timeline on the change of climate on Earth. And that was astounding. So they showed that the last major glacial was about 20,000 years ago. And they showed that the last major interglacial was a little over 100,000 years ago. And things have changed a bit since 1969, but not a lot. Their fundamental story has not changed. And that is probably the single most important paper in paleoclimate, and that came out of the Camp Century ice core. But so did all sorts of other things. The Camp Century ice core recorded major volcanic eruptions stretching back tens of thousands of years. because when big volcanoes erupt, they emit a lot of sulfur, a lot of acid, and that falls out of the sky in the snow. And so other Danish chemists were busy measuring the acidity of the ice. And the legacy of that ice core now, we've drilled so many others, is not so much the ice itself, much of which has been used up, but the 12 feet of frozen soil at the bottom, which we, and by we I mean a group of about 40 people in an international collaboration, have spent the last 4 years analyzing.
So what did you experience on April 4th, 2019 in Copenhagen, and what was its significance?
Early April of 2019, I got invited by a woman named Dorte Dahl Jensen, who by any means is the queen of Danish ice core science. She was one of the first women involved in the field. She's a very important, very powerful force in understanding the Greenland ice sheet. Numerous publications, worked with lots and lots of people, acquired ice cores. We had talked at a meeting, I think a year or two before in Buffalo, New York. She sent me an email saying, you want to come to Copenhagen and see the bottom of some ice cores? And I said, absolutely. So I had somebody else teach my classes, and I hopped on an airplane and I flew to Copenhagen. And we had a day of meetings and we talked to each other. And then the second day we piled in a small van and we drove to the brand new freezer that they maintain in Copenhagen for ice cores. And we walked in that freezer not wearing anywhere near enough clothing for well below minus 20 Celsius. Her husband, J.P. Stephenson, walked us over to a corner and opened up a box. And in that box were small white-lidded clear glass cookie jars with plastic bags full of what looked like chunks of dirt in them, sort of cylinders of dirt that were a couple inches high and a couple inches wide. And JP handed me one of those and said, this is the Camp Century sub-ice core. And we actually were holding it in our hands. And it was just amazing. And that's led to 4 great years of science after that.
So did they ever find out what actually happened to that permacrete and how it did end up in Copenhagen?
We have a good idea how it got from the States to Copenhagen when Chester Langway retired and the National Science Foundation shut down the ice core storage facility at the University of Buffalo. Almost everything from there went to the new USGS repository in Colorado, but that material didn't. Pretty clear that somewhere in the mid-90s it ended up in Copenhagen. But, you can talk to 10 different people and get 10 different stories of exactly how that happened. The good news is it was extremely well cared for once it got to Copenhagen. And that archive has remained frozen the entire time. It's remained intact. Of 32 samples, there are only 2 that are missing, and there are 2 that are thawed. For something drilled in 1966, it was in amazing condition when we got to it. And that's what's important. And it spawned this fantastic science over the last couple of years that has told us that the Greenland ice sheet shrank dramatically 400,000 years ago. And 400,000 years ago is a time of warmth. We know that. It's a time of warmth on the Earth. It's an analog for what we're doing today. And a large portion of that ice sheet vanished, which is a real warning to all of us.
So what are some of the other things that you've learned from studying that permacrete?
The word permacrete's an interesting one, and it's a mashup that the Army drillers used between concrete and permafrost. And permafrost is what dominates the Arctic landscape, where the average temperature is below 0 during the year, and it's frozen ground. But when we got these samples sent to us, they literally looked and felt like concrete. They were the average kind of soil you'd have in your front yard, but frozen solid. They were very difficult for us to work with until we thawed them. You need a diamond saw to cut the things open. And once you do, it's fascinating what you find. In these samples of permacrete, every one that we have processed are fossils. Not old fossils, not dinosaur bones, but fossils of plants that today grow in the Arctic. Fossils of small dwarf birch, fossils of mosses, bits of soil fungus, insect wings, insect eyes, insect legs, small bits of wood. It's amazing. We have found in there a frozen ecosystem. And that frozen ecosystem, according to the botanists that we work with, represents a tundra, a cold but yet non-ice covered Arctic environment. You go there today to Camp Century and there's nearly a mile of ice below your feet. But 400,000 years ago, the sun was shining on a landscape with little bugs and with things sort of maybe ankle to knee high that you walk through, covered with vegetation. Completely different landscape than it is today. And so I think that's the takeaway finding from this, is that there have been just major changes in the landscape of Greenland, and it's all preserved in a handful of sediment that literally you can hold in your hand, and you can pop under a microscope and see these fossils. And they look everything like they were buried yesterday.
You mentioned Chester Langway. What role did he play in this part of the story?
Langway started in 1956. He was a graduate from Boston University with his master's degree. He had come out of the military. He was hired immediately when he got out of Boston University to work with the Army Corps of Engineers in Greenland. And very soon after, went up to a place called Site 2. This was one of the Army's first under snow encampments. It was the first place they drilled in Greenland. They brought an old-fashioned Army drilling rig up there, as though they were drilling rock, and they started drilling. They drilled hundreds of feet in 1956, but they had a lot of trouble getting the ice out of the hole intact. They went back in 1957, and they did better. And then Langway started the process of analyzing this core from Site 2, did that through the late 50s, and then very clearly was involved in the drilling and analysis at Camp Century. If you look at the records of travel in and out through Camp Century, there are numerous occasions where he comes back and forth and clears customs, and there's records of that. So he was quite involved in the drilling, and then he became the curator of all these samples at Krell in New Hampshire in 2 very large freezers. And then in 1974, he moved to the University at Buffalo and continued curating those samples until the early 90s, when the samples moved to Colorado when he retired. So he is one of the reasons that, along with the Danes, we still have all this material, because it was so well curated for all those years and kept frozen, which is no mean feat. We've all had a refrigerator go bad on us. But imagine a refrigerator going bad that held the world's only deep ice core.
What is a healthy glacier, and why is Greenland's ice sheet so crucial to understanding them?
You know, we think about a healthy glacier as one where the amount of mass coming in is equal to the amount of mass going out. And that's a fancy scientific way of saying the bank account for snow is balanced. Think about it. If you spend more income than you have, you draw down your bank account, and at some point your bank account goes to zero and they start sending you overdraft notices. Sadly, glaciers don't do well with overdraft notices. They just vanish and you don't have a glacier anymore. So glaciers serve all sorts of purposes for humans. Arid regions and mountainous regions, they hold water that's useful for summer irrigation. But in places like Greenland, their biggest function that probably helps out humanity is simply holding water so it doesn't end up in the ocean and reflecting back summer sunlight. So think about that white glacial surface as a giant mirror sending back the solar energy. If it's not there and it's replaced by a dark tundra surface, a lot more of that solar energy is absorbed and a lot less of it is sent back to space. That leads to a feedback where, as the Greenland ice sheet gets smaller, less solar energy goes away and the planet gets warmer. As Greenland starts to shrink, the Earth is going to continue to warm. As the Earth continues to warm, Greenland will get smaller, and round and round it goes. It's one of the things that's quite worrisome to those of us as climate scientists, because getting rid of an ice sheet is a whole lot easier than rebuilding an ice sheet, especially when we have now increased carbon dioxide in the atmosphere by more than 50% over its historic level pre-industrialization. We show no signs of abating that rise. It continues to rise and to rise and to rise. So getting Greenland back once it's gone is going to be quite a trick.
So are you and others still studying the permacrete from those drillings in Camp Century?
Absolutely, we're still studying the permacrete. We have a very large National Science Foundation grant, and it involves 7 primary investigators in the United States, half a dozen collaborators abroad, 6 graduate students, a total of over 40 people from 4 different countries working on this. I would say we're about 60% of the way through, 70% of the way through our data collection, and we've only started writing up and publishing all this material. So there are several years worth of science for us to do, and the important part of this is we have only used up half the core. So the other half of the core is sitting frozen and safe in Copenhagen, because the next generation of scientists is going to find as much or more than we did from that core. This is the beauty of it. Had that core been used up in the 1960s, almost none of the analytical techniques we use today were around. And it would have been really hard to understand what was in those cores. Sure, people would have found the fossils, but they didn't find the plants. And they wouldn't have the ability to make the isotopic measurements we do now that allow us to date those sediments. And they wouldn't have been able to look at the molecules of the waxes on the outside of leaves that some of the scientists working with us are analyzing, nor date the last exposure to sunlight. None of these techniques were developed in 1966. So just as important as what we're doing is the fact that half of that core is going to sit frozen, hopefully for the next couple decades, until scientific techniques get even better, and we'll be able to learn more from it. It's a really difficult task to go down a mile and to get 12 feet of frozen soil. It's good to be cautious and to save some of that for later.
So in your book, you say Greenland's future is our future. How does that future look from where you are? And what is some of the collateral damage from Greenland's melting ice sheet?
So I say Greenland's future is our future, and I use the R very broadly. Because Greenland holds so much sea level equivalent, because it holds that 25 feet of sea level equivalent, all you have to do is look at a map of the world and start knocking off the major cities, the bulk of which are within 25 feet of sea level today. We can start in the US, right? You don't have to go very far from where we sit right now. Boston, New York. You can go south to New Orleans. You can go to parts of San Francisco. Then you can go abroad and you can look at cities all over the world, particularly in Asia, that are going to be very vulnerable to sea level rise. You can look at the island nations in the Pacific. Greenland is thousands and thousands of miles away from these places, but melting there is going to dramatically affect their future trajectory. I say it also because as Greenland shrinks, this planet is going to warm even faster because we've lost that giant reflector in the Arctic. Greenland really does drive in many ways our future as humans. Not that it's going to, the loss of Greenland is going to drive us to extinction. It's just going to change the way we live in a really major fashion. Me personally, I think it's a mixture of optimism and pessimism. Pessimism in that it seems to be really hard for our society to make the major changes it's going to take to save the world's ice sheets. That's Greenland, but it's probably also a significant portion of Antarctica, unless we change our ways and we stop emitting so much carbon. The science is absolutely settled at this point. There just is no debate among modern climate scientists that we are the cause for carbon dioxide rise in the atmosphere, and that the rise of carbon dioxide and other greenhouse gases in the atmosphere is the cause for the warming of our planet and the loss of ice. The question is what we're going to do about it. And how quickly can we decarbonize our economy? How quickly can we work toward other means of generating power? And can we find a way to get the carbon out of the atmosphere? And that doesn't necessarily mean things like carbon capture and storage, where we take the carbon out and we try to pump it deep into geologic formations. But it could mean reforestation. It could mean smarter agricultural practices. But as long as the amount of carbon dioxide in the atmosphere rises and as long as it stays high, it is dooming the ice sheets and the glaciers of this planet.
What do you hope the reader will take away from your book, and what can they do?
I hope the reader takes away from this book the absolute wonder and amazement of the people starting 5,000 years ago who inhabited Greenland, moving toward the explorers in the early 1900s, toward the men, and I say men because it was almost exclusively men of the military, particularly the U.S. military, who learned how to function in such an extreme and difficult and dangerous an environment. These scientists who were thinking about global change, 70 years ago. We think about this as a modern problem, but they were thinking about it generations ago. I think the other important takeaway for me, and this is where the optimism comes in, is these people tackled a wicked problem, a really difficult, complex problem of how to survive in an inhospitable land, and they did it. And I think to me that the bright side of this is that humans are smart. And humans are ingenious. And I think somebody out there living right now, maybe it's a 15-year-old, maybe it's a 30-year-old, or maybe there are many, many of them, are going to come up with the solutions we need to help us stop using fossil fuels that are causing the issues with climate, and how to find something better. That's the part of me that's really hopeful and optimistic. And that's one of the reasons I wrote the book, is it's such a fascinating story of ingenuity, intrigue, chance. But in the end, people manage to do something really amazing. And I have faith that people will do something amazing right now to help us address this crisis in climate that we have.
I hope you enjoyed this episode with Paul Bierman, and that you get the opportunity to read his new book, When the Ice is Gone. If you are interested in the work Paul is doing, please visit his website at paulbierman.net. If you enjoyed this episode, please share with friends, family, and colleagues. You can follow Nature Revisited on Facebook, Instagram, YouTube, or our website, nordenproductions.com. I would also like to invite you to share your comments and ideas, and even suggestions for future guests for Nature Revisited on the comment section of this episode on our website. The music for Nature Revisited is Tim Buckley, Buzz and Fly. Nature Revisited is produced by Stefan Van Norden and Charles Gagan, and I hope you will join me for the next edition of Nature Revisited. And in the meantime, do remember, we are nature.